Right, thirdly, we've had direction, we've had form, and now it's time for strength. We can only analyse the strength if we're looking at a linear relationship. So if we're looking at one of these kinds of relationships that we saw a minute ago. These non-linear ones, we can't talk about strength, it's not applicable. But like I said, most of the time we're going to be looking at stuff that is linear or making it linear. So we are going to be able to analyse for strength a lot of the time. So let's assume that it is for this instance. We're looking for what's called the correlation coefficient, or the R value. Now I know you've done that last year, but let's do a quick bit of revision. That's kind of like how strongly linear our data is. So is it really hugging tight to looking like a straight line pattern, and something like this one here, that's pretty tight into being a straight line pattern, whereas this one's a bit looser. So you'd expect that because this data is squeezed together a bit more, that would be a stronger correlation and a higher R value. Just like this is a bit looser, a less strong correlation and a lower R value. Well, let's have a look at a few examples of that. So if you have the data, then you'll put it in your calculator and you'll just get your calculator to tell you exactly what the R is, and then we can analyse that. But if we just have a graph, then we're going to look at it and sort of approximate what that might be. The basic set of what you'll do is find the correlation, Pearson's correlation coefficient, that's our R value, and then step number 2, we're going to just find the descriptor for it. And we'll use this table all the time, so make sure this table is in your summary book. So let me give you an example. If it was a strong positive relationship, like very closely hugged to a straight line and going in the positive direction, that's when our correlation, or R value, is going to be between 0.75 and 0.99, so quite high, because 1's like perfect. Like 100%. So it's sort of like a percentage really. Moderately positive relationship, that's if our R value is between 0.5 and 0.74. Like it's 50% of the tightness that it could be, so it's quite loose, and it's kind of just sitting still in that positive direction. So weak positive, really weak, the data's all spanned out, but it's still kind of going in a positive linear direction, so that's when we've got an R value between 0.25 and 0.49, and then when we start going negative, our numbers do the same sort of thing, but they go in the negative direction. So let's look at a few examples together. Here, there's no line going in any direction, it's just completely scattered, so there's no correlation at all, so we could expect that the R value will be 0. It's completely not linear. The correlation is nothing, doesn't correlate, it doesn't relate at all, so the R value is 0. Here is the complete opposite. These form a perfect line, absolutely perfect. You'll see that hardly ever in this subject. These form a perfect line together. The R value is perfectly, like 100%, exactly 1, and it's going positive, so it's a positive 1. Here, it's perfect again, a perfect straight line, but in the negative direction, so it's negative 1. You can't get any better correlation than positive 1 or negative 1. Here we can see that our data starts to loosen off. So let's even go to example 4 first. This is one of the tightest lines that we have out of all this data. It's starting to get looser and looser and looser here. So our strongest, most linear scatter plot is this one here. So it's going in the positive direction. You can expect the R value to be positive, and it's really tight, so you can see that about 90% of the rest of the space, if I show the rest of the space, is what's taken up. So that's why we could say it's an R value of 0.9. So like this will take up just 10%. It's not straying much from that perfect straight line. Let's find the next strongest one. I reckon that's about this one. I reckon about this much here and this much here. That's about 50% of our space. So our empty space is taking about 50%, so that's why our R is 0.5. So again, it's going in the positive direction, so we're going to say that's like it's going to have a positive at the front for the correlation, the R value, and it's about 50% of the space that it's taking up. It's pretty loose, I would say. Let's get, oh I missed this one, sorry. Here's another strong correlation. So this one, I reckon about 70% of the space is taken up here. So still quite a lot of this spare space is taken up. So here, about 30% sits in here. So this is the strongest correlation that we have here, strongest to being a perfectly straight line, still not perfect. This is our second strongest, but in the negative, so negative 0.7, like still quite strong. 0.5, it's about halfway there. It takes up about half the space. It's starting to sort of spread out. And here, it's really spread out. It's starting to spread so far that we've only got 30% or 0.3 left in this spare space here. So the less strongly linear it is, the lower the number will be in terms of our correlation. So 0, not at all. 1, 100%. Somewhere between them, different strengths. So we're just going to kind of approximate that, and we'll practice in class and we'll get better than that. But in general, it's easy to find, or good to approximate how much of the spare space we have, and that'll, in terms of a percent, and that'll give us an idea of what that R value is.